Hi, I'm Fishing Pole and welcome to part 1 of lesson 2 of my tutorial series on QMD. In the previous lesson, we built some basic facilities which will give us the essential resources needed to start QMD. In this lesson, we will be splitting it up into 3 parts. We will first see what are particles and how they work. Then we will create our first particle beam and then explore the mechanics and the construction of a linear accelerator. And finally, the beam that we just accelerated will be input into basic particle chambers in order to produce a variety of cool things. By the end of this lesson, we will know how particles work, how accelerators work, and how particle chambers work. And we're going to put all of that together to produce p-type doped silicon. And that is our goal for this lesson. In this first part, we will talk about particles. Particles and particle beams are QMD's unique addition to the TechMods ecosystem. Every particle beam is defined by 4 properties. The first one is the particle, which itself also has 2 important properties. A, the mass, which is measured in electron volts over c² and shows how easy it is to accelerate or bend it. And B, the charge, which shows if you can accelerate or bend it in the first place. A particle with a charge of 0 can't be accelerated or bent. The second property is the amount, which shows the required particle count for SPs or the particle flux for beams. It is expressed in particle units or particle units per tick. Both of these can be shortened to PU. Higher PU per tick means faster SPs but also higher focus loss. The third important property is the energy, which shows the speed of the particles. It is expressed in kilo electron volts, and any values that are lower than 1 kilo electron volt internally are stored as 0. All recipes require beams to have an energy in a specific energy range in order to happen. And finally, the focus, which shows how tightly together particles in the beam are. As the beam travels down the beam line, it loses 0.02 times, open bracket, 1 plus the absolute charge times the square root of the amount divided by 10,000, close bracket, focus per block. If the beam's focus becomes negative, that means the particles are too scattered to form a beam and therefore there's no beam. A standard 10 kPu per tick beam loses 0.04 focus per block, or in other words, 1 focus every 25 blocks. All recipes require a positive focus, but some recipes require a higher focus in order to happen, like the one we'll be doing at the end of this lesson. To create a particle beam, all we need to do is input the relevant fluid or item into an accelerator's ion source. All particle beams start with a focus of 0.4 as well as an output amount of 10 kPu per tick and 0 energy. We can also use a laser ion source which outputs 20,000 Pu per tick, has an output focus of 0.2 and the energy again is still 0. All beams can enter and exit multiplux with the relevant beam ports and can even do so while the ports are touching. However, if the multiplux are of the same kind, for example, we are trying to move a beam from an accelerator to a different accelerator, we have to use beam pipes. Beam pipes can be placed in the world and rotated with a multi-tool. For example, let's place this pipe here. I can click the multi-tool and as you can see it can be rotated in any direction. And this concludes the particles chapter. On to the recap. Let's do a little recap of what we saw in this video. We saw how particles work, we saw what are they, what defines them, and we also saw how do we create a particle beam. In the next part, we will talk about how do we build a linear accelerator and how it works so we can design it properly. And using that knowledge, we will then create our very first particle beam and accelerate it. So I will see you in the next part. Goodbye.